So for this question, we're asked to prove that the modulus of z2 is greater than the modulus of z1. And in this case, we're going to be looking at the complex numbers we used in the previous question. So we know that straight from the question, z1 was minus 1 plus 3i and z2 is 2 minus 4i, so I can just take down those quickly. So just to quickly refresh what is meant by modulus, so what it represents, and it is basically Pythagoras' theorem in disguise. So Pythagoras is kind of coming back to get us for the leaving cert once again, because the modulus is just the length of this kind of line for z2 and z1, so the length of the blue line here. And so we can clearly see z2 is a longer line. We can just see that visually, but we've got to prove it now using basically maths. So the blue line is going to be equal to the square root of a squared plus b squared, just using this little example here for z2. So we've got a being the kind of real component and b being the imaginary component. And so it's basically just an application of Pythagoras' theorem to find the length of the actual line that our complex number makes on the diagram. And so now, just using our definition of the modulus of the complex numbers, we can find out if the modulus of z2 is in fact bigger than the modulus of z1. So we can simply square the so 2 and minus 4 here in the case of z2, because we've got 2 minus 4i, and the minus 4 to be squared is going to be positive anyways. And then for z1, I've put on the right hand side is going to be the square root of minus 1 to be squared plus 3 to be squared. And so by simplifying this a bit further, we can see that it clearly is the case that z2 has a bigger modulus than z1. But we can simplify it right down to the very last third. So we've got root of 20, square root of 20 on the left hand side, and then we've got the square root of 10 on the right hand side, which is obviously smaller than that. And so we've proven that the modulus of z2 is greater than the modulus of z1.